If you clicked on this video, you probably already know how to use pointers, the syntax for them, and just the basics of declaring pointers and using them within your code. But you're probably still confused as for why. As a beginner programmer, it's kind of hard to understand why pointers are useful because we're making very small programs that kind of just, do basic arithmetic or just simple programs that don't take up a lot of space in the memory. But it's important to understand the concept of pointers early on. That way, when you're dealing with bigger data, you understand why we need them and you kind of have a bigger grasp on why you see them so much in C++. So, in this basic program, I have a function count that increments a number by 1. As you can see here, we pass in an integer. That integer is incremented by 1, and then we see out that integer. In this case, the integer that we're incrementing by 1 is the number 1. Let's pass that in and run this code. We should just get 2. Nothing new here, simple stuff. But there's actually a better way to do this. But before we get to that, let's just see what's happening behind the scenes inside of this program. This website right here is very helpful in visualizing what goes on behind the scenes whenever you execute your code. So this is our program that we had in Visual Studio Code. I just copy and pasted it here. And over here on the right side kind of shows us what's going on behind the scenes inside of the computer, inside of the memory stack here. So I will link this website in the description for your own use. I highly recommend just making a program and copy and pasting the code here and just kind of seeing what's going on. But for this example, let's trace over the code. So just to get you guys familiar, the red arrow just indicates what line is going to be executed when I hit the next button. And then the green arrow just indicates what line has just been executed. So line 6 here, nothing is happening, so nothing changed inside of our stack. But over here on line 7, we assign the value 1 to number. So when I hit next here, you're going to see here that number now will be 1. And let me just change this to show the memory addresses, just to make it a little bit more clear for you guys. So we have a variable here called number. It's an integer. We don't know what's inside of it yet. But after we execute line 7, we'll give it the value 1. Then on line 9, we will call our function count. So let's call our function count and pass in the value number. So you see here inside of our stack, we created a new function with its own variables. Count has the variable x, the local variable x here. We don't know what x is yet, but we will know soon when we pass in numbers. So let's execute this function line here on 12. Okay, so x has the value 1 copied from number 1 here. And I use the word copy purposefully because we're literally just copying the variable here. Take a look at these addresses here. This is FFF000BDC. This is all those but BBC. So this memory address here being different tells us that these are two different integers. Yes, they may have the same value, but inside of the memory, they're two distinct different integers. Think of it as like twins. Twins look the same, but they're not the same person. Let's go back to our code. On line 13, we increment x by 2, right? So let's do that. And notice what happened here. This changed to 2, but this didn't. And even if we see out x, yeah, sure, we'll get 2 in the output. We left number in the dark here by not mutilating it. And technically, on the outskirts, it seems like we incremented this number by 2. But inside of our memory, it still stayed 1. So how do we solve that problem? Well, we pass by reference, which is basically just using pointers. So let's go back to Visual Studio Code. And instead of passing number by value, we'll pass in number by reference. So I'll change it to the ampersand sign here, which basically means the address of x. And don't forget to change that inside of your function declaration as well. So now count, instead of taking in the value of x, it takes in the address of x. In this case, the address of number, which basically just makes a pointer for it. So let's do that same edit here inside of the website. We'll change this to integer address of x. And we will change this to integer address of x. Now let's visualize this code and see what happens behind the scenes. See how it's different. Okay, so same ball game. Inside of main, we have an integer called number. We will assign it the value 1. Then we will call in our count function and pass in our number, which holds the value of 1. Let's go to our count function here. So now x, instead of it just being an integer, x is now a pointer to an integer, but we don't know what it's pointing to yet. We didn't execute this line of code. We just know that we have a pointer called x. So let's run this code. What is it pointing to? It's pointing to number. And what is the address value of number? Well, it's this whole thing ending in BDC. So let's execute line 12 and let's see what happens. Yep. And you see here, x is a pointer to an integer number that holds the address of 000 BDC. And you can see here it's 000 BDC. Now, we have our pointer here. This x is our pointer. When we run this line of code, x++, it will increment the value at this address. The value at this address being 1. So we're doing the operation on the original variable. There's no copies here. None of that extra stuff. Just direct mutilation. So let's press next to run our x++. And you see here our number inside of main changed to 2 because we incremented by 1. And then we see out x again. And of course we get 2. So same output, but the difference lies within behind the scenes. Now we change number to 2. So I want you guys to kind of see the difference between what we did here and what we did when we passed x by value. In this case, number actually did change, and we achieved our goal of actually changing the original variable. So it may still seem a little bit ambiguous as to why we use pointers. Okay, cool. I can change, the original variable using functions, but like the output was the same. I still got 2 either way. Why do I care? Well, I'll tell you why you should care. Let's say we had a class, right? And classes, they hold like a bunch of variables. Let's just say class, blah, 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 blah. They hold integers, they hold strings, chars, and even arrays in some cases, right? If I was to pass a class object to a function, all of this stuff would have to be copied inside of our function. You see here? And just think about how much memory that would take inside of this count function. There would be so much copying going on. And in some cases, your program might not even run if there's too much copying going on and too many function calls. So what we want to do is we want to pass this object. We want to pass it by reference so that this object here, whenever it's used inside of the function, it's used as a pointer. And just like how x pointed to our number, if we pass in an object by reference, then whatever variables we have in here will be turned into pointers that point towards the object, and it will use that instead. Not only is that more memory efficient, but when we use the function call, we will actually perform the operations on the original object that is being pointed to instead of doing all this copying. So I want you to try to visualize what would happen if we take a class with a lot of data and try to copy it. Our memory would, our stack would actually just get overloaded. And that's what we call stack overflow. If you ever played a glitchy video game that starts lagging and stuttering, there's a very good chance that it's due to a stack overflow or some kind of memory leak. And that's why we use pointers. It's just for the efficiency, and passing by reference is just easier to work with overall. So even though pointers may be confusing initially, in the long haul, it'll make for more efficient code. So I kind of hope that gives you guys some perspective on why we use pointers. And I hope that kind of paints the picture of how efficient it is to use pointers, especially when you use bigger programs and stuff like that, where you're passing in objects to a function or maybe passing in structs. Just dealing with a lot of data, you're going to want to use pointers, or else you're going to end up overflowing the stack, or causing memory leaks and stuff like that. And it's just not going to be fun. So yeah, I hope that helps. I'll see you guys in the next one.